we're headed towards an era of tiered cloud architectures. That we have, the clouds that we kind of know and love, the public cloud, the commodity cloud, the Amazons of the world. But that we are moving towards edge clouds, access clouds, the need to be able to deliver compute and applications close to end users. And the primary reason for this, we actually heard some good proof points this morning, but it's that edge processing is becoming vital. It's recognized now universally, I think, that it is vital. It is, next generation networks going to require processing at the edge. And I try to capture just, one or two key reasons so that you understand why this is so universally accepted at this point. This is one way to sum it up. That human reaction time is measured in less than a quarter of a second, depending on what kind of sense you're actually trying to measure. And the latency to the centralized cloud can easily exceed that. And we're talking about all these next generation applications like augmented reality, like autonomous vehicles. So imagine, augmented reality is about you're wearing a set of glasses, and as you move your head around, there's text labeling the buildings you're walking by. And if that text doesn't stay still as I move my head, the user gets nauseous. And so for that to be a reality requires a level of latency and processing speed that is impossible if you centralize those operations. They need to be pushed close to the user. Autonomous vehicles, there's a vision of being able to pack more vehicles onto the road, to be able to compress the space between the vehicles. But if a car has a blowout up ahead, that has to be signaled down the chain for there to be sort of universal synchronized braking for that to work properly. Again, that's not something that you can go to a centralized cloud to go do the processing. And then a third one I think is really interesting is just around IoT, because we often think of IoT as maybe not a lot of data, maybe it's a power meter that once a day is going to get a message or do something. But one of the most critical factors in IoT is battery life. And the goal here is to have devices that the battery can go for 10 or 20 years without having to be replaced. And studies have shown that when a device wakes up, even if it's once a day, sends a message. If it has to wait that 100 milliseconds, 400 milliseconds for the commodity cloud to reply, that has a substantial impact on overall life and battery life. Whereas if the processing can be pushed to the edge, you can get double or triple the battery life out of a device. So yet and again, another good example now across the spectrum of 5G, of IoT, and augmented reality, where edge processing is really where the action is. And I think we see universally across the industry now that much of the effort, much of the vision is going into the edge, into the central office or the head end for traditional providers. So, what is it that's needed differently in an edge data center versus a centralized data center? Well, we've come to know the data center, piles of racks, spine leaf fabric, and then WAN interfaces to the outside world, right? And we've also come to know that, the notion or generally these data centers have lots of east-west traffic. There's more traffic going between servers to be able to, crunch on a request than there is going in and out. 80, 90% is east-west, 10, 20% is north-south. So that's the Amazon data center, the Google data center, the big data centers we think of in the commoditized cloud. But the edge data center is very different. It has very different characteristics, and it needs some specialized consideration. So again, you start with the same core architecture, if you will, right? But and where I had WAN before, I've now put I/O. But the first thing is that in these kind of data centers, they are I/O-centric. I mean, it's all about bringing in subscribers into the network. And the subscriber traffic is not just 10 or 20% of the overall network. It is now 50, 80% of the network. And so you have to be able to scale that part of an edge data center in a very different way. And by pushing it down to the leaf of this architecture means you can scale it out. You can have 1, 2, 3, 10, 20 copies of this I/O piece. It scales just like servers scale in a spine leaf data center. Now we're able to do that with the I/O component. In a similar way, we move the I/O for the WAN down to a leaf node. And the two can then scale independently and without limit, depending on what you need in a particular installation, or as traffic grows or as subscribers grow. And then thirdly, we need to be able to onboard subscribers and access network, which is quite unique, and it depends on what kind of access network you're talking about. You know, this is a GPON example, but you know, there's mobile wireless, 5G, there's DSL, there's cable. So there are unique ways in which access subscribers are coming in at the edge of your network, and the cloud has to be able to accommodate that. And the Chord architecture natively you know, addresses that. This is just giving you a detail of what the you know, an open GPON solution looks like. It's a white box, though it looks black, it's painted black here, but it's a white box Ethernet switch in essence that has specialized optics plugged in for GPON. And so it gets all the white box economics. It simplifies the optical access to its minimal essence, if you will, and all of the control logic is moved into the cloud in a virtualized form. And so it's getting, you know, it's making it as pure cloud native as possible, but still addressing the reality that you have to find ways to bring subscribers onto the network. So I want to speak about you know, this in the context of ONAP, because ONAP is a relatively new open source initiative and announcement. It's about 4 weeks old at this point in time, and you may or may not have heard a lot about ONAP at this point. ONAP is a Linux Foundation project around orchestration. It comes from the merging of eComp, which was an AT&T, that is the software AT&T has been using in production for 2.5 years. It's now been open sourced. 5 to 7 million lines of code that's now been open sourced through the Linux Foundation, now merged with OpenO, which was an open source initiative largely driven by China Mobile, the world's largest mobile operator. Those two have come together, they're merging, and the resulting project is called ONAP. It's an orchestrator, a global orchestrator, designed for VNF onboarding, license management, service chaining, service creation, to be able to deliver services to users. And the way Chord and ONAP work together, you know, Chord is also a Linux Foundation project. You know, AT&T is one of our founding partners. We're working quite closely together on bringing these pieces together. Think of it as you still have the, you know, the core telco cloud or even commodity clouds that are orchestrated by ONAP, but that Chord as an edge data center with its unique properties has a different place at the edge of the network where there are many copies, but they're smaller installations. They're edge focused, access focused, and ONAP can then do end-to-end service orchestration between them. So one way you can think of it is that Chord allows subscribers to come onto the network and then allows VNFs or microservices to be defined and orchestrated and instantiated and presented northbound to ONAP, and ONAP sees them as VNFs that can then be service chained to VNFs that are also included in the core cloud and all chained together end to end. That's really, I mean, this is emerging work. You know, where we have our sleeves rolled up and we're doing quite a lot, but that's where it's going at this time. So, you know, back to this, you know, picture, we were talking about the edge cloud and the commodity cloud and what's in the middle. So, you know, where we are seeing things come together is, you know, at the access edge, Chord in its many variants, and you know, this is a highlight kind of presentation, but there's R-Chord for residential ultra broadband, and M-Chord for mobile, E-Chord for enterprise VPN business services. There are lots of variants of Chord focused on different types of access users. Then with the telco we're also seeing quite a bit of activity around internet exchange clouds or sort of intermediate clouds. And then also, you know, of course, the commodity clouds that we all know and love. That we think there's a place for all three, that they all have special properties. They're actually built slightly differently, and that services need to be orchestrated to stitch them all together as appropriate. So I want to say something too about Chord, because I realize in this deck of slides it looks a lot like hardware. We're talking about switches and servers and a spine leaf and all of this, but it's very, I recently had this question posed to me a couple times in a forum like this. You know, Chord is not about hardware, but it is true that if you go to the Chord wiki, it's an open source project, you'll find a BOM, a bill of materials that tells you what you can buy, how to plug it all together. And if you plug that gear together, you can press a single button and it will download and build and deploy across all the servers and switches and come up. so it makes it very easy. But you can, of course, customize and change out and swap out components and whatnot. But more importantly, Chord is really about software, and it is a complete software distribution with a couple of different variants that I mentioned focused on different markets. And so it's truly a cloud-native solution for edge service delivery. It's not just networking, it's not just any single component. It's tying together all the components you need to create an edge cloud. And so what that looks like, hold on one slide, and then I'll dive in. So, I've also found that there's confusion about a number of the ONF projects and the different variants of Chord. And so this slide I included to just try to lay that context and that framework. So from an ONF perspective, there is ONOS, which is a platform. It's an SDN controller that then has a number of use cases that are deployable. A packet optical solution, which is an IP WAN backbone that's in production. NTT just announced a new trial. It's in 7 or 8 productions in networks worldwide, and many more that are not public that we know of where it's getting used in other ways. And then there's also, based on ONOS, a spine leaf fabric. So a full white box spine leaf fabric for the networking component with a scale-up, scale-out architecture. We don't talk about it a lot. There's so much going on at the ONF, it's frankly hard to talk about all the pieces. But that spine leaf fabric gets used inside Chord. And then there's Chord, which is a full cloud-native platform, and it's not just a slice sitting on top of ONOS, but it has lots of different components built into it. And then a number of solutions built on Chord. And I mentioned these earlier, R-Chord, M-Chord, and E-Chord for different markets, different access technologies, if you will, each its own multi-billion-dollar market. But we found that the Chord platform is very flexible, and by changing out just some access technology, you're suddenly able to go after a whole different vertical and very rapidly craft solutions that can have a significant impact on an adjacent market. But diving into Chord, really my last meaty slide, is that Chord is not just a layer on top of a network, but Chord is really a curated collection of dozens of open source projects. It includes a full infrastructure as a service. So OpenStack is inside Chord. And in places where OpenStack's been getting some bad press, well, we've done things with OpenStack to make sure it plugs in with the rest of this infrastructure. So you don't have to go and download OpenStack and figure it out and start to figure out a Neutron plugin and get it all working. I mean, Chord provides this all in a prepackaged, boxed solution, if you will, and including Kubernetes for containers and whatnot. A full networking solution based on the ONOS controller, but much more. A full DevOps environment, so you get the full, true cloud-native environment to get everything that DevOps offers. A full infrastructure, and then lastly, but not least, is a full service creation environment with yet another project called Exos, which is allows you to create complete NFV VNF services, stitch them together, and then to automatically instantiate those as subscribers come on to your network. So, in closing, I just want to say that there's a lot going on at the ONF, and this is just a taste of what's happening. Since this happens to be a local show, I wanted to mention that we have a boot camp that's also going to be local in San Ramon, hosted by AT&T, May 23rd, and I invite you all to learn more if you're interested. It's a day-long event to really understand the scope and breadth of everything that's going on at ONF and to help you consume. And figure out if it makes sense for you to get more involved. So with that, I encourage you to learn more. I think there's something quite amazing going on here. The activity level that we have is kind of beyond what we can handle to some degree. You can see our tier 1 partners, both on the operator side and on the vendor side, and we have beyond this an ecosystem of over 200 companies that are working with us. Okay. Thank you very much.